Hello, my name is Jono and I'm a licensed cadastral surveyor at Eliot, Sinclair in Christchurch, New Zealand. Today I would like to talk to you about a series of surveys we at Eliot Sinclair have undertaken as part of the road and rail rebuild following the magnitude 7.8 earthquake on the 14th of November 2016 centred near Kaikoura. The earthquake caused major damage to road and rail lines running along the coast, rendering them impassable. The road and rail rebuild was estimated at approximately 1.2 billion New Zealand dollars. Coastal engineers commissioned us to supply survey data in the gap between where conventional hydrographic survey could be undertaken and the low tide mark. This gap ranged from between 50 to 500 metres depending on typical sea conditions. This slide shows the typical area in which our surveys were undertaken. Marine vessels could only safely navigate to the far left of the image, while conventional ground crews could only reach to the far right. As you can see, in the centre of our image is our survey solution, which involved the use of a Trimble GNSS receiver and a UAV. As conventional and hydrographic surveys were both not possible in the area, we developed a technique using a Trimble R8 Model 3 GNSS receiver attached to the top of a consumer-grade off-the-shelf UAV. Below the UAV, we mounted a camera and hung a fishing line with mechanical tension sensor, emergency quick release and large fishing weight. Prior to fieldwork, we used the GPS planning tool within Trimble Business Centre to predict the number of satellites and also the dilution of precision. We utilised an obstacle file to take into account the steep terrain adjacent the site. Once on site, the GNSS base was set up and activated, and the R8 unit was also powered up and set to log data. We control the UAV using an app which allows us to set run lines and waypoints. The UAV automatically navigates to the next point before allowing the pilot or surveyor to take control of the altitude. The ground crew and pilot monitor the tension sensor using the video feed from the onboard camera. Here you can see the UAV lowering in elevation until a mechanical tension sensor is activated, at which point the pilot hovers at the elevation for half a second or so before raising the line out of the water and progressing to the next point. Checks are completed at regular intervals by dipping points on land with known positions. Upon return to the office, the logged data from the NetR9 base station and the R8 rover are downloaded and imported into Trimble Business Centre and processed. The top half of this slide shows a screenshot of the plan view of the data, while the lower half of the slide shows a 3D view of the data. We undertake a review of the data in 3D to ensure that quality has been captured and inspect any dips which the pilot or ground crew have identified as needing further attention. The trajectories were then exported and processed by a third-party software to extract the lowest points for each dip. This image shows the reduced data with only the lowest dip points overlaid on an aerial photograph of the area. The cyan points represent the run lines initially required by our client. Based on the delivered results and the success of the innovation, they requested additional run lines and points as shown in green. A CSV of the lowest points was exported from the third-party software and read back into TBC. A surface and contours were then created. Each dip was then inspected to view its relationship with the extracted lowest points and the surface. The delivered data to our client included an ASCII file of the point data and also a digital surface. This image was supplied by our client after integration of our dipping data into their database. The green points in this image are the dipping points, the white are the conventional topo survey, and the red lines is the hydrographic data obtained from the survey vessel utilising Trimble Hydro Pro software. You can see that the data knits very well together. This series of surveys was only possible with clever innovation and the combination of multiple systems to acquire the survey data in the areas that are very hazardous environments. I wish to thank our team at Eliot Sinclair for their Kiwi ingenuity and our client for entrusting us to deliver a quality product.